Good afternoon, students. So let us move to the problems on Thevenins theorem. Okay. Find the current in the 10 ohm resistor circuit shown in the figure by using Thevenins theorem. But here so many resistance across 180 volts. But here 30, 30, 13, 17. 13, 17, 30, 30 ohm, 12, 12, 4 and 8. But here 13 plus 17 is series. Right now? 13 plus 17 is series. The same thing 4 and 8 also series 12. Here 12 ohms, 12 ohms, 12 ohms. This is the delta. Here 13 plus 17, 30, 30, 30. This also delta. This delta is converted to star. First step number 1, open the load branch, remove the 10 ohm. This 10 ohm is removed. The basic 10 ohm will be, this 10 ohm will be removed. Across VTH we calculated. Before VTH you calculated delta to star. This is also delta, this also delta. Find the open circuit voltage V Thevenins. Convert 12 ohm delta to star having each resistance. This is also 12, 12, 12. This is 12 into 12 divided by 12 plus 12 plus 12. The answer is 4. The same thing 30 ohm, 30 ohm, 30 ohm. Again you converted delta to star having each resistance 30 into 30 divided by 30 plus 30 plus 30. This is 10 ohm. Answer is 10 ohm. Now 4, 13, 34, 10 one side. This is 48. 38 plus 10, 48. The remaining 4 plus 10. Okay? 4 plus 10. But you calculate current, the voltage is 180. 180. This is 38 plus 10, 48. But here 4 plus 10, one more. Okay, this is V by R. 180 divided by 4 plus 48 plus 10. Okay, this is open. 4 plus 10 plus 48. It's current. You get answer is 180 by V. 180 by R. What is V? 180 divided by R is 4 plus 48 plus 10. This is 4. This is 10. Next, this is 48. Answer is current 2.9032. Like this, 4 plus 34, 10, 48. 4 plus 10, 14. Remaining 4 and 10 as it is. You now calculate current also. Just now calculate current. Across VT, first you find out, trace the path A from B. A from B. This is voltage. First you find out voltage. V Thevenins, open VAB. VAB equal to 48 into I. 48 R. This is a ohm. 48 into I. This I. 48 into I. What is the current? Just now calculate 48 into 2.9032. Answer is 139.3548 volts with the positive. This open circuit. The next you calculate resistance. This is 48. 4 plus 34, 10. 48. This is 14. These two parallel. Remaining as it is. 4 plus 14 parallel with 48. These parallel. The answer is total is 4 plus 14 parallel with 48 plus 10. Answer is 24. 24.8387. It's the total resistance. Okay. Next, Thevenins equivalent shown in the figure. Same 48, 14 parallel, remaining 4, 10 as it is. Just now calculate R equivalent. Next, you draw the Thevenins equivalent circuit using R equivalent and VTH. Just now calculate R equivalent. V Thevenins also calculated 139.3548. R equivalent 24. RL is 10 ohm. Across RL you calculate the current load. VTH by R equivalent plus RL. What is VTH? 139.3548 divided by 24 plus 10. Answer is 4 amps. Okay, next problem. The exam problem 2010 July, 7 marks. Find for the network shown in the figure, find the Thevenins voltage, short circuit current, determine the actual current flowing through the 6 ohm resistance. This is open first. Why? Because of through the 6 ohm resistance current will be calculated. First you open the EV, remove the 6 ohm resistance. First step. Remaining as it is. Just to show the current direction. 18 volts. I 1 ohm. This is Vx because of just given in the diagram Vx. Next 2Vx AB is open. Calculate open circuit voltage VTH. AB is open, 3 amperes. This is 3 amperes. 3 into 1 because of I into R. Vx is I into R. 3 into 1, 3 volts. Next, tracing the AB plus minus 2 Vx, 1 ohm, 3 volts, 18 volts. Here 2 into 3, 6. What is the Vx? 3 volts. 2 into 3, 6 volts. 3 volts, 18 volts. 18 plus 3 plus 6, 27. Total voltage is Thevenins 27. Next, short the branch AB. This is short circuit. Here I2 plus I1 is 3 amps. Same direction. I2 plus I1 is 3 amps. Short the branch AB. Calculate ISC current. ISC is nothing but I2 value. Because of the short circuit current is equal to I2 current flowing to the second loop. So ISC equal to I2. This is I2 plus I1 is 3 ampere. Equation number 1. Next, apply the KVL to the super mesh. This is plus 2 minus I1. Next, plus 2 minus I1, plus 2 minus 18. Next, 2Vx equal to 0. What is Vx? I1 into 1. I1 into 1. This is I1. Next, just to substitute I1 value in Vx. 2I1, 3I1, minus 3I1. Minus I1, minus 2I1. What is Vx? I1. Minus 2 into I1, 2I1. I1 and 2I1 minus 3I1 minus I1 minus 3I1 minus 18 equal to 0. So I1 equal to 18 by 3 minus 6 amps. But here I2 minus I1 second loop. I2 minus I1 equal to 3. Already find out I1 value 6 ampere. That's why you substitute 6 ampere. I2 minus 6 equal to 3. What is I2? 3 plus 6, 9. Next, you calculate R equivalent VTH by ISC. Already calculate VTH. What is VTH? 27 by 9 ISC. That is 3 ohm. Next, Thevenins equivalent shown in the figure. This diagram. R equivalent value substitute. VTH R equivalent to 3. VTH 27 ohm. 27 volts, not ohm. 27 volts. RL is 6 ohms. Next, you calculate IL. VTH by RL plus R equivalent. 27 by 6 plus 3. 27 by 9, that is 3 amperes. Okay, just stop the video. Remaining next video lecture. Thank you.